Hello there, this is Miss Page, and in this lesson we are going to look at problems in which we will need to be calculating the volume of a sphere. So when we're looking at the volume of a sphere, it's actually, the formula for this one is not one that we have to adjust like we do for prisms and cylinders, where we have a general formula such as capital B times H, which is our capital B is base area. And for pyramids and cones, we've learned that we have 1/3 times our base area times height. And then we have to adjust for the base area shape and use the appropriate area formula. For a sphere, it is all given to us. It's just something we have to learn or memorize. So the volume of a sphere is equal to 4/3 times pi times the radius of the sphere cubed. And the radius of the sphere goes from the center of the sphere out to the edge of the sphere. And there are different ways that we will be asked to find radius. Sometimes we have to find it from the diameter. We also sometimes have to find it from the area of a great circle. So a great circle is a circle that has the same center as the sphere, and its circumference is on the outside edge or surface of the sphere. And so we can work backwards using area of a circle formula to find radius that way. Sometimes also circumference. Knowing the circumference of a great circle, we can work backwards and find our radius. The other thing that we sometimes encounter in problems related to spheres is a hemisphere. And hemisphere is half of a sphere. So the formula for a volume of a hemisphere then can be calculated by taking our sphere formula and multiplying times a half, which is shown here. And then our 2 and our 4 reduce, and we get 2/3 instead of 4/3. You can kind of think of half of 4 is 2, and that gives us half of the sphere. And so we have 2/3 times pi r cubed for our hemisphere. All right, let's take a look at a problem. So in this one, this figure represents a spherical helium-filled balloon. And it's a tourist attraction that allows up to 28 passengers at a time. And they ride in a gondola that is suspended underneath the balloon. So somewhere here there's a gondola. And the balloon cruises at an altitude of 500 feet. So the question is, how much helium to the nearest 100 gallons does the balloon hold? And we have a conversion ratio here that 1 gallon is about 0.1337 cubic feet. So we have a measurement here of 72 feet. So what we have to understand too is that the information about the number of passengers and the altitude that the balloon cruises at for this ride are not necessary pieces of information to actually calculating how many gallons of helium the balloon will hold. That's all based on this conversion ratio and an understanding that, well, the helium is going to be on the inside of the balloon filling it up. That's a capacity situation, which is a volume problem. And so we need our cubic feet calculation, and then we can convert to gallons. So this 72 feet here, we have to recognize it goes all the way across the middle of the sphere, and it's all the way across. This would be a great circle right here, and so this would be our diameter. So in order to calculate our volume for our sphere, we of course need our radius, so that's what I'll do first. And radius is half of diameter, as we know. And so our 72 feet divided by 2 gives us a radius of 36 feet. So now we can calculate volume in cubic feet using our formula now for volume of a sphere, spherical, like shaped like a ball. And so we have 4/3 times pi times the radius cubed this time. So now we're looking at 4/3 times pi times our 36 feet cubed. So that's a quantity cube. So again, we have to understand the structure here means we have to cube 36 and cube feet. That's going to give us our cubic feet units, but we also have to cube the 36. When you use your calculator to do 36 to the third power, your calculator very likely does not have an x cubed key. So what you have to use is the generic exponent key, which often, or at least in the classroom calculators, looks like a caret. So you type your 36, your exponent key, and then follow with your exponent value. When you do times 4/3, the best way is to do 4 divided by 3, then do times pi, then times your 36 cubed. All right, let's use our calculators. All right, so our value here, we should be getting about 195,432, and then we want to carry this out a few decimal places for accuracy. So I'm going to carry it out 3 decimal places to 196, and that would be then in cubic feet. So now we have our volume, but it's in cubic feet, and we want to know how many gallons, in this case, of our helium will the balloon hold. So now we have to convert to gallons. So we have our volume in cubic feet, and then we can use our conversion ratio. So that's a denominator of 1. And we want to get rid of those cubic feet. So we put the cubic feet in our denominator and our gallons in our numerator. So we know now that the math we're going to have to do is our volume number, our 195,000 number, divided by this 0.1337. And let's use our calculators there. All right, so this is going to give us a number of 1,461,722. That's to the nearest whole number gallon. But what I'm looking at, again, remember, the rounding was nearest hundred. Notice it ends in a D. That means it's talking about the hundreds place in front of the decimal point. And there's my decimal point. So my hundreds, this is my ones, my tens, my hundreds. I am rounding to this place. That's my hundreds. And so the 2 would make the 7 just stay a 7, and then the 2's become 0. So we get about 1,461,700 gallons. Then we can write our conclusion. So remember, it's how much helium in gallons does the balloon hold. So the balloon will hold about 1,461,700 gallons of helium. Like so. All right, let's move on to the next problem. So here we're looking at a composite figure. It sort of looks like an ice cream cone, or ice cream cone with ice cream on it. And so we've learned how to do composite volumes. This time we have to realize that what our composite figure is made up of here, because it doesn't tell us. So in looking at this, we have to recognize that this portion here would be a cone, and that this portion here is half of a sphere, which we call a hemisphere. So our composite volume is going to be the volume of that hemisphere added to the volume of our cone. Hemisphere, remember, is half of a sphere, so that would be 2/3 times pi times radius cubed, plus the volume of our cone, we have learned, is 1/3 times our base area. And our base area, our capital B, is area of a circle, because cones always have a base of a circle, so that's pi r squared, times the height of the cone. All right, so what we need is the radius of the hemisphere, we need the radius of the cone, and we need the height of the cone to calculate our total volume. Now here, this 5 centimeters, notice it's pointing at this line segment, which goes from the edge of the circle that's both at the bottom of the hemisphere and at the bottom of the cone, and it goes to the center. So that is the radius for both the hemisphere and the cone. What you have to be super careful of, and we've talked about this, is remember height h is always perpendicular to the base of its figure, in this case the cone. So here's my right angle right here, which means that, remember, this measurement is our height, h. That 13 there is talking about the slant height measurement, which we've learned is called L. So in order to find our height h for our cone, we're going to have to use our Pythagorean theorem here. Remember that our Pythagorean theorem would be r squared plus h squared equals L squared. And so we'd have our 5 squared, don't really need that, I'm not going to worry about units, plus our height squared equals 13 squared. So these are nice whole numbers. If you wanted to, you could figure out what they are. This is 25 and this is 169. So you have h squared equals 169 minus 25. Taking your square root of both sides, you're looking at your height h being the square root of 144. And hopefully you recognize this is actually a perfect square. And the square root of 144 is 12. So our height is 12, and the units would be the same as the radius and slant height here, so it's in centimeters. So now we can go back to our volume formula. We have the measurements that we need, radius for both, height for the cone. So our total volume is going to be 2/3 times pi times the 5 centimeters cubed in this part, plus 1/3 times pi times 5 centimeters squared in that part times the height of 12 centimeters. So here, 5 cubed, that's 125. And here, 5 squared is 25. Now, I would do all this math at once in my calculator. So I would do 2 divided by 3 times pi times 125, then plus, I'd probably do pi divided by 3. You could do 1 divided by 3 times pi also, then times my 25 times my 12, it equals, and then I'll round to the nearest cubic centimeter, which remember would mean the whole number place, the nearest ones place, whole number. All right, let's use our calculators. All right, so hopefully you agree with me. To the nearest cubic centimeter, you should be getting about 576 cubic centimeters. So the context here is simply volume of the composite figure, so that will be our conclusion. The volume of the composite figure is about 576 centimeters cubed, or cubic centimeters, like so. All right, we'll now be moving on to the next problem. All right, so looking at what we're looking at here is a gumball is in the shape of a sphere, shown here, an example. It has a spherical hole in the center, so like if you bit it in half or cut it in half, it would be empty on the inside, and if this was not all a little bit squished, it would form a nice perfect sphere of its own. How might you calculate the volume of the solid portion or solid part of the gumball? What measurements are needed? So we've done problems similar to this before with other types of solids where we remove part of something. And we have learned that what we have to do is subtract off the volume of what is being removed. the measurements that we're going to need, since both of these, both the gumball and the hole inside are both spheres, the only measurement we need to calculate volume of a sphere is its radius. We have to realize the radius of each of these is going to be different because the hole will be smaller on the inside than the gumball itself. So we will need to know the radius of both the gumball and the hole it's inside, and then we can subtract the volume of the hole from the volume of the gumball, and that would be then the solid part of the gumball would be what we have left in the math. All right, let's take a look now at a problem where we apply that concept. So here we have a gumball. The gumball has a diameter of 3 centimeters and it's shaped like a sphere. It has a spherical hole. This is our situation that has a diameter of 1 centimeter. And we want to know what is the volume of the solid part of the gumball. And we will round to the nearest tenth of a cubic centimeter. So we're good there with units because we have centimeters already. All right, so first off, I want to keep track of what's what here. So this I'm going to say is the radius of the gumball. And that would be half of the diameter of the gumball. So half of 3 centimeters gives us a radius of 1.5 centimeters. We also need the radius of the hole that's inside that gumball, and that would be half of the diameter of the hole. So the diameter there is 1 centimeter, and dividing that by 2, that's half, which you can leave as a fraction, or you can write it as the decimal, 0.5. So what we're going to do is figure out the volume of our gumball, which would be 4/3 times pi times the radius of the gumball cubed, and then subtract off the empty part, which is the hole inside. That would be a volume of 4/3 times pi times the radius of the hole cubed. So again, I would do this all at once so I get the most accurate answer. Saves time too. So I have 4/3 times pi. The radius of the gumball would be 1.5 centimeters, and I'm going to cube that, minus 4/3 times pi times the radius of the hole, which is 0.5 centimeters, and I will be cubing that also. So again, I have to realize I'm cubing the 1.5 and my centimeters, cubing the 0.5 and my centimeters. So in the classroom calculators, you have to use the caret key, followed by the exponents. 1.5 exponent 3. And here would be 0.5 exponent 3. All right, so let's use our calculators. All right, and hopefully you are getting, when you're all done, to the nearest tenth, remember, about 13.6 cubic centimeters. So this, remember, represents the volume of the solid portion of the gumball. So the solid portion of the gumball has a volume of about 13.6 cubic centimeters, or centimeters cubed, like so. All right, we are moving on to the next example now. So I mentioned at the beginning of the lesson during the concept portion that we can be asked to, we have to know the radius of the sphere to find its volume. And there are actually different ways that we might have to find the radius. So in the problem so far, we've seen finding the radius using the diameter. Here, though, we have to realize, so we want to find the volume of the sphere, and in cubic centimeters, which is good because we have centimeters, but we are given the circumference of a great circle as 14 pi centimeters. So here we have to realize to find the radius of our sphere, we need to work backwards from circumference. So we actually need to know what is the circumference formula for a circle. And that isn't something we have used recently. So we have to know that circumference is calculated using radius as 2 times radius times pi. What this allows us to do is we know our circumference is 14 pi centimeters. So we can put in the circumference spot our 14 pi, and that's equal to how it was calculated as 2 times radius times pi. And then we can solve this little equation for r. So we're going to divide both sides by 2 times pi, because it's both of those we want to undo. And what will happen here is our pi's will reduce to 1, and our 14 divided by 2 gives us 7. And over here our 2's reduced to 1, our pi's reduced to 1, so we just have r. So our radius is 7. Our units would be the same as circumference, linear units, so 7 centimeters. And then we can go on to finding volume. So that would be 4/3 times our pi times our radius of 7 centimeters quantity cubed. So again, we have to cube that 7 as well as the centimeters. And here we're in around to the nearest tenth, so now we can use our calculators. And hopefully you're getting this number. So we're at about 1,436.8 cubic centimeters. So simple context, just volume of the sphere. So the volume of the sphere is about, oops, I don't have an exponent on that like I should. There we go. Is about 1,436.8 cubic centimeters. There we go. All right, one more problem we want to talk about together to go. Let's take a look at it. So this one is similar to the previous one, where we've got a sphere. We just want to find the volume. This time we want it in cubic inches, which is good because we have an inches measurement here. It's actually inches squared, you might notice. We're going to go to the nearest tenth again. So what we need, of course, before we can calculate volume is the radius of our sphere. This time we have to, it's A here stands for area, and what it's pointing at is this circle in the middle of our sphere. So that is a great circle. So that's area of a great circle. And just like any circle, its area is calculated the same way. So we've used this one a lot with other problems. We know area of a circle is calculated as pi r squared. So we know area is 81 pi square inches. So I can put that in my area spot. 81 pi must be equal to how it was calculated, which is pi times radius squared. And again, I can work backwards to solve. So I would undo the multiplication first, dividing both sides by pi. Pi divided by itself is 1, so this gives us 81 equals r squared. And then taking the square root of both sides, again, principal square root, because radius has to be a positive number. 81 is a perfect square, so our radius gives us 9, and our units would be the square root of our inches squared. So we're actually square rooting inches squared also, which gives us inches, as we would expect for a radius measurement. So now we can find our volume. So that would be 4/3 times pi times our radius of 9 inches, quantity cubed. So again, we have to cube the 9 and the inches. We can use our calculator now and round to the nearest tenth. And hopefully you're agreeing with my number. So we should have 3,053.6 to the nearest tenth inches cubed. So conclusion here, just volume of the sphere. So again, the volume of the sphere is about 3,053.6 cubic inches, or inches cubed. All right, so that is all of the example problems that we are going through together, and now you should be ready to begin your assignment. Have a good day.